I know roughly it is like, this is a graph question, so I found my general direction. So what I need to do, right, is I need to be comfortable enough to take a small little step, a small little step, a small little step. Because every small little step that I don't mind taking, I'm closer to my destination. The worst is, for some of us, the moment we see this, right, whoa, I've never done this question before, I better look at the solution. The solution actually won't teach you this. Okay, let me take a look at my solution. My solution, right, I didn't even use any H2 math stuff at all, in my solution. Which means that this question here is totally about your problem-solving ability. What are the first few things that you think you can try to do? Anyone, any suggestion? Just something that we can, take a micro step. Sorry? Okay, so Wesley says, maybe we can substitute to solve this. Okay, because the question indeed require me to, we cannot say that there's no math at all. So there must be something still a bit math about it. So Wesley decided that, okay, I'm going to use simultaneous equation. Why simultaneous equation? Because that is the hint that is given to us by the question, right? Because the question talks about the intersection between this and this. The graph of this cuts the parabola at 4 real and distinct points. So when graph cuts, algebraically, it is simultaneous equation. So we don't mind doing a bit of simultaneous equation. So x squared plus y minus k squared. This is equal to 25. And we have this. We have 4y, this is equal to x squared. Or I can also see this as y is equal to 1/4 x squared. Either of this. So I'm going to, let's say, call this equation number 1. We're going to call this equation number 2. We're going to take micro steps. As long as it is still mathematically sound. Okay, I'm not taking random steps, okay? I'm applying logic to how I want to progress. Okay, so I'm going to try solve simultaneous equation, but please remember, please remember, you will be expecting yourself to do some trial and error. And the trial and error doesn't indicate that you don't know how to do, doesn't indicate that you are not going to get the marks. Trial and error is part and process of how you are going to get some answers, some solution in H2 math. So for example, I've decided that I'm going to do this, and I'm going to sub this into here, okay? So we have, I'm going to sub, let's say, equation number 2 into equation number 1, okay? So if I were to sub this as my equation number 2 into equation number 1, then we have this 1/4 x squared minus k squared is equal to 25. Okay, I am already seeing a problem. I'm going to continue first, okay? This is one good micro step. This is good. It is not going to get me my solution, but this is good because this shows my adaptability to what H2 math require me to do. That flexibility, that ability to become more versatile. So let me show you why I can really see this is potentially a problem. This will be x squared plus 1/16x to the power of 4 minus away 1/2 kx squared plus k squared. This is equal to 25. The problem is I'm working on a quartic polynomial, x to the power of 4. And according to theories, because we are moving on more and more into theories already, that means according to theories, right, it is actually not very easy for me to be analyzing something that is x to the power of 4. It's not very easy for me to do so. Because I have no other theories to back me up. And that is what some students will do, like what I was saying just now, right? Okay, try this. Stuck. You look at the solution. Oh, okay, that is how it is supposed to be done. But the problem is, you will still not be able to do it. What else can we do? We did that last week, right? Last week we did our algebraic analysis and comparison, and I was telling you guys that algebra is going to be one of the best tool. Graph is going to be the next best tool. Graph is very, very important for our H2 math. So what are the, if this fail, is there any other alternative? Last week we tried to keep thinking about different alternatives. Is there any other alternatives that you guys can think of? Let me ask one of you on the who are at home, okay? Can I ask how about Bernice? Not Rebecca, but Bernice. Bernice, do you have any suggestion, Bernice? If I were to just stick to this, okay, I'm going to continue with simultaneous equation. That is the hint that I'm going to be giving you, okay, Bernice? Can you tell me, is there any other way that you can probably solve this simultaneous equation so that maybe it is going to make sense? Can you think of any, Bernice?
I don't think so.
You don't think so? Okay. Sichuan has another idea. Because it is still solving simultaneous equation. Simultaneous equation is definitely the right direction because it is about the intersection between two graphs. So what if we don't choose equation number 2 as this? What if, like what Sichuan has said, right? What if we choose the simultaneous equation as this? If I were to choose the simultaneous equation as this, then I'm going to be replacing this. So I will still do a substitute equation number 2 into equation number 1. So we have a 4y plus y minus k squared. This is equal to 25. And if I were to just expand this, we have a 4y plus y squared minus 2ky plus k squared. This is equal to 25. I can even rearrange this further because I will have something that is actually not just familiar to me, but I have tools that can help me to process this further. Quadratic equation, quadratic expressions. Of all the polynomials that you have learned before, it is one that has the most tools to analyze it. That is why if you were to do any algebraic manipulations, do any algebraic stuff, right? To me, my preference is usually, if I can get quadratic, I will just try to get quadratic instead of quartic, instead of cubic. Because quadratic, I have completing square, I have quadratic formula, I have discriminant. In fact, quadratic is the only polynomial that we study as topic to learn how to process it further. The rest, we just study as one polynomial by itself. Okay, this is easier to process, but do you realize there's still a problem? Right, because this is quadratic. So what do you think you will do? Discriminant? But you know what this question says? This question says that there are 4 intersections. This I can understand. Because if I were to do it this way, right, it's not like there's no advantage at all. But if I were to do it this way, I know that there are going to be possibly 4 roots, 4 intersections, because it is x to the power of 4. But if I were to do it this way, it is y to the power of 2. That means it is indicating to me that there are only 2 y coordinates. Does it mean that there are 2 intersections? Because the question says that there must be 4 intersections. What other things do you think we can do so that we can try to piece all this information together? And this is not difficult. Okay, that's why don't be pressurized by this. Okay, we got to learn to adapt to this. And once we can adapt to this, our H2 math will usually start to become better and better in the exam. If you don't study hard, you will still fail in the exam, okay? But in the exam, we will start to become better. Is there anyone who can suggest to me some other micro step that probably we can take? Let's move on from simultaneous. Okay, simultaneous seems to be still correct, but I need some other steps. Something that is a little bit more different. Is there something else that we can do so that we can process the question a little bit better? Anyone, any suggestion? Edgar, do you have any suggestion? Anything else that, or any one of you, if you can think of some suggestion, right? I don't mind trying out on the board, but logical suggestions, okay? Logical, something logical. Anything, Edgar? Or Claudia? Anything that you can think of that maybe we can try? Can you think of anything that can help us to, so that this whole thing, when it comes together, right, it is logical? If even it seems like you have thought of something, what do you think of? Okay, if it is too random and illogical, then don't say. Is it logical?
The circle will like move up and down the line.
Okay.
So like it goes like further and further away.
Okay.
Now the circle
Okay, let me describe to you guys what Vivian has just said, okay? Vivian says that it is going to be like that, then it's going to be like that, then it's going to be like that, then it's going to be... Vivian said that it is this. You know what Vivian is trying to ask me to do? Come on, just draw that curve so that we can all visualize together. That is part and parcel of how we are going to be solving for this. You know, the question didn't ask you to draw the graph. That is not part of the instruction that is given. But I think that can be one critical part of my solution. I initiate this. Let's sketch the graph, okay? Let's sketch this thing, then after that, you know. So what Vivian is trying to say, right? We have a circle. Let me draw this circle first, okay? So we have this circle. We have this circle where the center is at 0, k. And we have this parabola, which is going to be a smiley face. And the question says, right, that they are going to be intersecting at 4 real and distinct points. So I'm going to try to draw something which is what Vivian has just tried to describe to me, which is I'm going to try to draw this. Okay, it will definitely be cutting here. The graph of y is equal to 1/4 x squared will definitely be touching this. Okay, so this one I cannot change. But if I can just adjust the circle a little bit, it is actually possible for me to get the two graphs to be cutting each other at 4 distinct points, correct? You know what we have done? I mean, imagine if you were to look at the solution, and if the solution provide if the solution provide for you this diagram, right? Do you know how much easier it is going to be for you? But if the solution didn't provide this, in the exam, you are left with yourself to decide whether you want to sketch or not. And if you just don't sketch, if you just keep reading, and you decided not to sketch, you know the chances of you getting this correct in the exam is going to be even... It's already a difficult question, but the chances will be even smaller. Okay, so can you see? I mean, I can see the logic already. Okay, based on this diagram, I can understand the logic. Why is it that when I express everything in terms of x, I will have 4 solutions? 1, 2, 3, 4x coordinate. Based on this, I understand why if I were to go for y, I will have only 2 solutions. Because for y, they are symmetrical about the y-axis. So there are 4 intersections, but there will just be 2 distinct y coordinates. This y and this y. y1 and y2. And please remember, okay, we have so far not used any H2 math theories at all. And how difficult is this question? Very difficult. It's very difficult to be done in an exam. No H2 math theory. But this was tested in the H2 math exam. Why? Because H2 math doesn't require us to just use theory. H2 math also requires us to use all the math tools that we are being taught to solve problems. So now this makes sense. Right? Now this makes sense. In order for me to have 4 intersections, I need to have 2 distinct y coordinates. And to have 2 distinct y coordinates, I'm going to let the discriminant here be bigger than 0. Right? To have 2 distinct roots to this equation, I'm going to let the discriminant be strictly bigger than 0. So 4 minus 2k b squared minus 4ac, this is bigger than 0. If you were to work on this and to find k, you will end up with k to be less than 29 over 4. Okay, we have a 4k squared, 4k squared, y squared. Yep, we are going to be left with square. Yep, we're going to be left with a k is less than 29 over 4. Okay, this will give me a minus, this will give me a 4k squared. This will be a minus 4k squared, so k squared will disappear. It will become a linear equation. I'll get this. I mean, just trust me, okay? This one is just equation. But let me say something else, okay? This is still not going to be correct. There's still something that is missing. Can you think some more? What is missing? So from this, you will probably be getting 2 out of 3. If the teacher is generous enough, I believe the teacher may even give you 2.5 because it is almost completed. Can you guys think where is the part that is missing? We just need to spend time to think. Where is the part that is missing? Logic. look at this diagram. This diagram is going to be very, very critical and helpful. Is there something that doesn't seem to be logical enough? Okay, Wesley has something to say. Okay, Wesley is imagining, because k is less than 29 over 4. And if you were to look at this, where is k? K is the center of the circle. So if k is less than 29 over 4, this implies that this circle can just keep going down and down and down and down, right? What if the circle goes down all the way until, let me use red color to draw the circle that goes down, okay? What if this circle goes down all the way until it gets this? What if the circle goes down until it is here? If it is here, then there's no intersection. Because the value of k, like what we have just done here, right, is strictly less than 29 over 4. If the circle is here, then there's still intersection, but there are only 2 intersections. So this is also not what we want. So we need to imagine again. Based on the diagram, this is what I'm going to try to imagine. I know, oops. So I know my parabola looks like this. Okay, this is the x-axis. My parabola looks like this. Okay, and okay, I mean, I'm okay drawing a circle that is here. And like what Vivian suspected just now, which won't work. Vivian suspected that we will use the diameter, but we know we cannot use the diameter of the circle. If you were to think about it, the diameter, I mean, we cannot use the diameter of the circle because okay, we just cannot use the diameter of the circle. Okay, I don't know how to explain this, but if you were to shift this up, right, the place where the circle cuts the graph is not like it's going to cut at the 2 diameter area, you know, because the parabola is slanted. So it's going to be cutting at, you know, like the circle is here. So it's going to be like, I don't know how to explain, okay? So just try to imagine. But we already have this, k is less than 29. So this circle cannot go too high up. Once the circle flows too high up, right, then it is possible that the circle is not touching at all. But the circle cannot go too low. The lowest it can get must still be a circle with a radius of 5. That is the lowest it can get, okay? It must still be a circle that is higher than this circle, right? It must still be higher than this circle. You can imagine this, right? It must be higher than this circle. Remember, when it is higher than this circle, it will cut at 4 points. If it is this circle, it's going to be cutting at only 3 points. And what is this circle with a radius of 25? This circle will be at 0, 5 if it were to be like this, because the radius is going to be equal to 5. So the center must be at 0, 5 in order for this part to be 5, which means that my answer is not going to be just this. Yes, k is going to be less than 29 over 4, but we also need to make sure that k is strictly bigger than 5, correct? It must be strictly bigger than 5. It cannot be even 5, because if k is equal to 5, then we will have just 2 intersections. We will have just 3 intersections. If you were to ask me, this kind of question is more fun than the A math kind of question. It's more fun if we are able to do it as a revision. We don't need to rush. We don't need to make sure that we pass our exam. It is very fun. Okay, but sadly, this kind of question will appear in our exam, and it is not easy for everyone to study this kind. Some of us has already developed that kind of ability to solve this for some of the experiences that we have in our life so far. But some of us, maybe we still need some prompting, you know, for us to get this. But regardless of what, right, I need you to recognize that this is part and parcel of solving H2 math and getting higher marks in the exam. Only when you recognize it, then it is possible for us to work on using the next few months, you know, leading to your J2s and stuff, right, to work on this aspect. Let's continue with part 2. Part 2 will also require us to do a little bit of analysis, not as bad as this. But from part 1, this is what we have already determined. From part 1, we have determined that k must be between 5 and 29 over 4. K must be between this. And when k is between this, I know the scenario is going to be like this. Let me just very quickly draw it out. Okay, so you have 1, 2, 3, 4. Then we have another curve. We have another curve, part 2. We have another curve, 4x squared plus y squared minus 2y minus 24. This is equal to 0. This graph is going to be transformed with a translation of 6 units in a positive y direction, followed by a stretch. Stretch is not such a good word to use. Usually they will say scale. Okay, but anyway, they have already used stretch. Stretch parallel to the x-axis with a scale factor of 2. Find a new equation. Okay, this is graphical transformation, which is not the analysis part of graph that we were talking about. I'm going to just assume that you guys have the knowledge of this transformation for this, okay? But if there will be some time today, if not, we can continue next week. We are going to look at a bit of transformation, and the transformation for this Diamond High, for this VJC and Diamond High, they are also not very easy. So I'll rather spend some time looking at the transformation from that. But from this, right, let me show you like the very first part, okay? I look at this, although I can work on this, but I know this is going to be compared to part 1 because of the way that this part is asked. Give a reason, the number of times this parabola, which is actually this also, will be cutting the new curve. So I know this is going to be very much related to part 1. Okay, I've gotten these hints. The question didn't ask me to do the next step, but I'm going to try to initiate it myself, which is to re-express this into something that look a bit more like a conics. So this will be 4x squared plus this y minus 1 squared minus 1 squared minus 24. This is equal to 0. So I have this plus y minus 1 squared is equal to 25. Okay, I'm going to just stop here, of course. It's not of course, it's like I'm going to stop here, although I can still re-express this a little bit more by making this to look more similar to the first part. Okay, but I think this is, to me, is enough. At least it looks similar enough. Okay, so this is going to undergo 2 transformations. The first one, translation of y units in the positive y direction. So we are going to replace all the y by y plus y minus 6. So it's going to be translated by 6 units in the positive y direction. So the first transformation, I'm going to replace y by y minus 6 is equal to 25. Then we will have a 4x squared plus y minus 7 squared. This is equal to 25. Then x is going to be stretched parallel to the x-axis with a scale factor of 2. So I'm going to replace x by half x. That is what I've already memorized from my graphical transformation. So replacing x by half x squared plus y minus 7 squared, this is equal to 25. So half square is going to be 1/4 multiplied by 4, I will have this. Y minus 7 squared, this is equal to 25. This is the equation of my new curve. Even if you didn't do this, and if you start to do all your replacement, in the end, you're still going to get something that is similar to this. Okay, so this step is not super necessary, but this step is something that I'm predicting that I will find it useful later. Again, this is part of our problem-solving skill. It is not because we are taught to do this, okay? So the question ends off with, state with a reason the number of times that the parabola y is equal to this parabola. 4y is equal to x squared. State with a reason the number of times this parabola will be cutting the new graph. So from here, it's not that difficult. This one is easier already. Okay, but from here, we need to do some inference. From here, it is almost like k is equal to 7. Right? And what is 7? 7 is a number that is between 5 and 29 over 4. 29 over 4 is 8 point something. Okay, so between 5 and it. So how many times is going to cut? It's going to cut at 4 times. Why? Because the first part has already given me that hint. Okay, and you guys can understand what I'm trying to say, right? Is there any H2 math inside here? No, 0. Let's not talk about circle, okay? Circle, we have already learned this in our A math. So we didn't actually use any new H2 math theory in question number 7. Which means that this question number 7 could have also appeared in an A math exam. But I can assure you, if this question were to appear in the A-Math exam, it is going to be broken up into a few parts. Because for A-Math, it is very much still going to be the hand-holding part of swimming. It is still very much going to be the hand-holding part of cycling. A-Math is that. H2 Math is the part where the instructor is supposed to let go. Let me show you another one. And I thought this one is